What's going on, everyone? Homework assignment 36. Today's objective: I can identify the differences between correlation uh, and causation in relationships. All right, we've already done some work on correlation. Correlation just shows that as x values increase, y values will also increase. Okay, so that would be a positive correlation. As x values increase and y values decrease, it gives us a negative correlation. All right, so we want to identify the difference between correlation and causation. So causation is when a change in one quantity causes a change in the second quantity. A correlation between quantities does not always imply causation. So just because, let's say, there's a positive correlation, doesn't mean that it's always going to be causation. So the other day, one example I think of is we saw the example of the students scoring on the students' test scores on the math test and the science test, physics test. As the students scored better on the math test, their scores would generally go up on the physics test. So does that mean that every time you do well on a math test that you're automatically going to do well on your physics test? No. There's other things that are going to come into play, okay? If it happens to be the case, then that's fine. But doing well on your math test does not automatically cause you to do well on your physics test. Maybe there's a slightly better chance, maybe you're more mathematically inclined. Maybe you studied real hard for both of them. Or the other way around, maybe you studied real hard for your math test and not so hard on your physics test. Therefore, you may not do well on your physics test, all right? A lot of other factors come into play, and that's what we're going to identify, is that there's causes, and there's causation, and there's correlation. So generally, to determine whether two variables have a causal relationship, you have to carry out an experiment that can control for other variables that might influence the relationship between the two target variables. All right. So a lot of examples you'll see, there are no experiments carried out where we could fix those other variables. So we can't really justify that a lot of relationships are causal. More of them are just have correlations toward each other, or positive or negative correlation. So let's see really the two examples that we're going to see. And then there is another video I do want you to watch that maybe explains correlation and causation a little bit better, but I'll send you there afterwards. So let's see the two relationships here. A student found a positive correlation between the number of hours his classmates sleep before a test and their scores on the test. So he basically found that as his classmates got more sleep, they did well in the test. Can he conclude that he will do well on the test if he goes to bed early? So think about it in your case. If you have a test the next day and all you're doing to prepare for it is going to sleep early, are you going to do very well on that exam? Not necessarily. Maybe you will, maybe you won't. But there are other factors in play. So other factors could be study time. So studying. What are other factors that could come into play here? If you go to class, do you do homework? So there's a few other things that come into play here. It's not just if you go to bed early. Otherwise people would go to bed early all the time and just do really well on exams. But it doesn't work like that. There are other factors. So he cannot conclude that he will do well on the test if he goes to bed early. There is no causal relationship there. All right. Second example, a lifeguard notices that as the outside temperature rises, the number of people coming to the beach increases. Can she conclude that the change in temperature results in more people going to the beach? Well, it seems like you can, but you really can't. So we can't say, as our temperature rises, that more people are going to go to the beach. That's not necessarily the case. In some instances, it is the case. But there are other things that come into play. For instance, the other weather. So what if it gets really warm, but it's pouring, raining, a thunderstorm outside? Is that going to tell you to go to the beach just because the temperature went up? Probably not. Probably not going to want to go to the beach. Let's say if the temperature goes from 20 degrees to 30 degrees, is that going to make you go to the beach? No. All right. It got a little warmer, but it's still below freezing. So we could say, where did the temperature start? And then the other side of that, let's say it's already 100 degrees out and it gets up to 130 degrees. I don't know about you, but I don't like to go to the beach. I wouldn't like to go to the beach if it was 130 degrees outside. I'd probably be blasting the air conditioning, staying inside, staying cool, because I'm not going out and feeling the wrath of that heat. No shot. That is not for me. So, can she conclude that the temperature change results in more people going to the beach? No, we can't conclude that because there are other variables in play, okay? Take a look at the other video. Take a look at the two practice problems that I'm having us pose, and we'll talk about it in class. But take a look at that other video. It'll shed a little bit more light on causation versus correlation. And I'll see you next time.